Hello everyone, I will be presenting my project on modeling an insurance company database system using a star schema dimensional modeling. This model helps streamlining the analysis of key data such as claims, customers, policies, agents, and performance and fraud detections also. So let's dive in. So first, what is a star schema? The star schema is a data modeling approach that organizes data into a facts and dimension tables, allowing the fast querying and reporting. So, compared to other data modeling schemas or data modeling approaches, star schema helps us to access the data or access any sort of data from the database very easily because of the dimensions it is divided. The one is a fact and other is a dimension tables, and at the center of the star schema are the fact tables, which hold the transactional data. Around them are the dimension tables, which provide context to this data, like customer, policies, or agents. So, for example, in this, as a model, I am developing a database for an insurance company. The claim table will be the center will be at the center of the database, that it will be a fact table, and around it the database like customer the tables like customer and date of the insurance claims, those will be there. So first of all, let me show you. Yeah, this is the structure of our database. First, at the center there is claim. Then there is agent table, customer table, payment table, location, claim table, date, and for the two tables extra there that are for fraud detection and policy. This table will be used to detect any sort of if any sort of fraud or any sort of policies is added to the database or not. So now let's move to uh, the structure of how this whole database is built. So on the screen, you can see that is the SQL code for the claim table. And the claim table has the following columns. One is claim ID, policy ID, customer ID, agent ID, claim date, claim amount, status. And where status has a constraint to check the status must be approved, rejected, or pending. And a claim type also have a constraint to check it should be accident or theft, and time to settle also. Most of the columns in this claim table are of data type integer. One is a varchar, that is a string, and that is claim status, and claim type is also a string. So this is a fact table. As you may know, like fact table is at the center of the database, as I previously explained. So the for further table that I will be explaining will the dimension tables that are surrounding the claim table. So first, the key dimensional tables, the important dimensional tables that must be there for the database to work properly. The first is the customer database. Customer database contains the basic information of all the information about the customer. And that is the first of all the customer ID, that is the primary key. The customer name, gender, age, address, the marital status of the customer, and the employment status. Also, the risk profile that is having a constraint to check it should be low, medium, or high. Now, the further three tables that we have as the dimension table is a policy table. It is policy ID, policy type, coverage type, premium amount, policy start date, and policy expiry date. And the two tables left are the agent ID, agent name, agent region, agent type, with a constraint to check the agent type should be independent broker or company employed. The last dimensional table is the is the date column. That contains the date ID, a date column, a month column, quarter, year, and a fiscal period. So, as you may as I have shown you the structure of the database earlier, there was a fact table. There was a fact table, or I can say there's a fraud detection table or premium payment table that can act as a additional fact tables, because They can be a standalone table. They don't need any other type of table to surround them, or through which they need to be connected to get access to get any sort of information from those tables. So the fraud detection tables is first of all the fraud case ID, that is the primary key, the claim ID, the detection date ID, fraud type, and fraud status. Only the foreign key here is the claim ID that we will be accessing from the claim fact table. So the second additional fact table is the premium payment. This is also the a fact table which doesn't need any sort of dimensional table to surround him or to connect it to it to get any information out of this table. The first is payment ID, that is the primary key, then policy ID. That's for the policy ID and a payment date ID, that are the two foreign keys that are attached to this table, and payment amount, then payment mode. Additional dimensional tables that we can add are the claim type and region. These tables are not important, but we are adding this because they can be needed in some cases. So the one is claim type, a description about all the claim, what is the type of this claim, and the region table. Region table is about if a customer enters any region in the database and we want to know which region from which country is this region from, then we will need to save the data somewhere in the database. So this is a ER diagram of the whole database, the main database, that is the one fact table, that is claim table, and the four dimensional key dimensional tables, the customer table, policy table, agent table, and the date info table. Okay, so now let's discuss about the business use cases, the claim analysis. The star schema enables detailed analysis of the claims by various dimensions such as policy types, regions, or claim type. This way we can analyze the claim as a authentic one or it is a fraud. It helps us to compare the claim type, it is a auto, health, life, which type of insurance, and the region also, and the claim type also. This is accident, theft, or fire, or any sort of claim type it can be. And the second is premium analysis. Premium analysis is to track and analyze the customer premium payments over time and identify trends. It will help us to compare the trends or compare the whole trend of the company in previous quarter on in this quarter, or the how the customers are reacting to this any sort of policy they are getting. So how we can track it. First of all, we need to get the payment history, and we will need to do the customer segmentation according to their region, age, risk profile, or employment status. And the next is the policy type, and the policy type can be of auto, health, life, anyone. The third use case is about the fraud detection. Fraud detection is the pattern which will need to identify in the fraudulent claims. This can be done with the help of any ML model. We need to identify, it can be a decision tree, it can be anything. It can be a SVM also, it can be a linear regression also. So for how we can get it, first we need to compare the claim type, location, and agent analysis to detect if either it is a fraud or not. Claim type can be of staged accident, location, and the agent analysis. The fourth and the last business use case can be the agent performance. If we need to detect the performance of any of the agent that works inside our firm. So how we can do that? First of all, claim handling. We will need to analyze the number of claims processed by each agent and their resolution times, customer satisfaction, and the region-wise productivity. We need to differentiate or segregate the regions according to the productivity the agent are showing in that particular region. The agent type, it can be an independent broker or a company employed agent. Okay. So now let's discuss about the benefits of star schema. First is easy data querying and reporting. So why did we choose this star schema data modeling approach? We could have choose the snowflake schema data modeling approach or a traditional one, but we choose the star schema because we want to get the data very easily. We don't need to write complex queries, or we don't need to. get data which takes time. What is it? This is used for the transactional processes that needs processing very fast. So for that, the star schema, like compared to any other data modeling approach, plays the best role. First, in a star schema, we can easily query the data and get the data fastly compared to other modeling approaches. And second is the improved decision making. It also helps to make proper querying and to improve decisions in many ways possible. And the scalability for large data sets. It helps us to make the data set scalable. For example, in this insurance database schema, there was a center of the database that was the claim claim table. That was the fact table of this database. So if the data sets can be easily scalable, we can attach any other dimensional table, or we can make other fact table and attach dimensional table to that. So the scalability of this data sets is compatible with scalability of this database is compatible for large data sets and supporting predictive analysis. So predictive analysis, for example, in this insurance database, we made a fact table known as the fraud detection table. That is why we can like it is because it supports the predictive analysis for any type of like fraud detection, premium policy detection, and in for other examples, if you want to take, we can say like in uh, yeah, for example, we can take customer churn, like the customer will be converted to a long-term customer or it will be just a one-time customer. For that, we can use this star scheme also because it supports predictive analysis. So that was the end of this project, the dimensional model for insurance company. So thank you for watching the whole video. The project was focused around a star schema model to organize and analyze the complex insurance data. Thank you.